Hello everybody, welcome to our NEET Physics by Arun video channel. In today's video, we are going to solve a multiple choice question in the chapter Magnetism and Magnetic Effects of Current. This question has been asked in the NEET examination in the year 2021. Somewhat different questions. So you look at the question, a uniform conducting wire of length 12A, 12 into A, and resistance capital R is wound up as a current carrying coil in the shape of number 1, an equilateral triangle of side A, and then number 2, a square of side A. In both the cases, current will be passing through the circuit is I, capital I, and you are asked to find the magnetic moment of the coil. Okay, that's it. Okay. The magnetic dipole moments of the coil in each case respectively are how much? Option 1, root 3 Ia square and 3 Ia square. Number 2, 3 Ia square and Ia square. Number 3, 3 Ia square and 4 Ia square. And option 4 is 4 Ia square and 3 Ia square. Which one is the right answer? That we are going to find out. So magnetic dipole moment, rather to say magnetic moment of the coil, capital M is equal to capital N Ia. Let it be equation 1. So magnetic moment, M is the magnetic dipole moment, N is the number of turns in the coil, that you know very well, I is the current passing through the coil, and A is the area enclosed by the coil. This sort of problems, this sort of issues that you come across in the Bayes-Sauer's law and ballistic galvanometer experiment or something like that. Okay, the theory of ballistic galvanometer. Okay, so how to find this magnetic moment? In both the cases, we have to find it. In the case of equilateral triangle, the length of the coil is 12A. Usually in both the cases. So you can make 4 equilateral triangle of side A, because if the equilateral triangle had a side A, then the circumference of the triangle is A plus A plus A, 3A. So with the length 3A, you can make one triangle. With the length 12A, if the length of the coil is 12A, we will make 4 similar equilateral triangles. It means what? Number of turns is 4 triangles. 4 coils in the shape of equilateral triangle. Okay. Then area of the equilateral triangle. What is the area of the equilateral triangle? So this is the equilateral triangle, and this is A. You draw a normal, it is perpendicular, it is this. So, what is the area of this triangle? The area of the triangle is given by 1 by 2 into base into perpendicular distance. What is base? A. So, what is this perpendicular distance? If this is A and this is A by 2, totally it is A, this is A by 2, and this perpendicular distance will have root 3 A by 2. Okay, root 3 A by 2. Okay, so according to Pythagoras theorem, you can find it root 3 A by 2. So area of equilateral triangle is equal to 1 by 2 into base A into perpendicular distance root 3 by A by 2, root 3 by 2 into A. So totally it will become root 3 A square by 4. So substituting the values in equation, capital M is equal to NIA, number of turns N 4, I current through the current through the coil, and A, area of cross section of the equilateral triangle. So root 3 A square by 4. So this 4 and this 4 gets cancelled. 4 in the numerator and 4 is the denominator. It means what? Root 3 Ia square. Root 3 Ia square is the magnetic dipole moment of the coil, which is in the shape of the triangle with 4 number of turns. Number of turns is 4. Then for what about square? Now you consider the case of the square. The length of the coil is 12A. So it can make 3 squares of side A, is it not? So the length of the square is A. The circumference of the square is A plus A plus A plus A, 4A. With the length 4A, you will make 1 square. With the length 12A, you will make 3 into 4a 12a, is it not? So 3 squares. It means what? The number of turns when you make the coil as a square, the number of turns will be 3. What is the area of the square? You know, a square. If it is for an equilateral for any triangle, the area is 1 by 2 into base into perpendicular basis. In the case of square, it is a square. Is it not a square? So substituting the values in equation 1. M is equal to N I A. So 3 N number of turns. I is the current to this. Capital A is the area of the area enclosed by the coil. What is A square? Number 3 I A square. So the magnetic dipole moment of the coil for the equilateral triangle is root 3 Ia square that you have seen in your previous slide. And for the case of square, it is 3 Ia square that you have seen here. So the magnetic dipole moment of the coil for equilateral triangle and the square are root 3 Ia square and 3 Ia square respectively. Out of 4 options, answer option 1 is the right answer. Okay. So you will see one more questions. So this is a somewhat peculiar question. I have to think properly before solving this question. Okay. So anyway, we will see another question in our next video. Till then, thank you one and all. Okay.